So this is double number 3. We have the 12 equations that I have to balance and explain the solubility rules behind them. So this first one is Na3PO4 plus MgSO4. All these are double replacement reactions. So we're going to have to, switch them. Okay, so first we're gonna go with Na3 Na3 and SO4 SO4 plus MgPO4. Oh, and this is gonna be a 2-part thing divided up with 6 equations. So I'll be sending 2 videos for this one. And I'm just gonna balance these first, and then I'll go over if they're, soluble and all that. Okay, so plus MgPO4. Now, I think this is balanced because other measures, not all the measures, like, they all cancel each other out, so that's a balanced equation right there. Okay, so now we're gonna go to the second one. PbNO3 times 2 plus H2SO4. Now, excuse me. Okay, so what we're gonna do is just do the same thing. We're just gonna go with PbSO4 plus HNO3 plus HNO3. So for this one, NO3 and H they just don't cancel each other out. So what we're gonna do is we're gonna put a 2 in sorry, I'm a little stuffy. So we're gonna put a 2 in front of it. And since NO3 has the 2 minus charge, so yeah, has the 2 minus charge. And that's balance right there. Now let's go to the third one. We have FeCl2 plus H2S. So same thing. All you're gonna do is FeS plus HCl. Now, I believe Cl has a -1. a +1 charge. So does NO3. NO3 has the +2, not the -2, the +2. So I believe Cl has the +1. So we're just gonna cancel that out with like the H by putting a 2 there, and there you go. So now, the next one, which is KCl plus H2SO4. Now, simple, we're just gonna switch it as HCl plus K2SO4 plus K2SO4. Now, so this is not balanced. The both Cl compounds are not balanced. So what we're gonna do is put a 2 in front of the KCl, put another 2 in front of the HCl, and there you go, the charges balance out. Now let's go to the next one, number 20. We have, so we have an ACl, and I was gonna put a plus sign, sorry, NaCl plus H plus H2O. Since there already is an H right there, we can just say H2O. And I believe this is balanced already. So yeah, yes, this is balanced. So you don't need to do anything with that. So now 21 is gonna be the last one of part 1. So we have FeBr3 plus BaOH parentheses 2. So simply put, we're gonna do what we've been doing. Just switch them up. FeOH OH3 plus BaBr2. And as you can see, the coefficients stayed where they are. Stayed like the 3 and the 2 here. They stayed where they are because they just don't move. They're always idle. You never change. I mean, not coefficient, subscript. You never change the subscript no matter what. So now, what we're gonna do is, this isn't balanced here. So what we're gonna do is, let me think for a second. I see. So we're gonna put a 2 in front of FeBr3 and a plus B, and we're gonna put a 3 in front of the BaOH2, and then what you do on the reactant, you gotta do the product. So we're gonna put a 2 there, and then 3 there. And there you go. There's a balanced equation. So now, solubility rules. This one, we can figure them out easily. So for number 16, A3PO4 and G. So right here we have sulfate. We have the sulfate, and I believe these do. Yeah. This is soluble because there are no exceptions here. So now we have PbNO3 No. For this one, we have a sulfate and a nitrate. So for nitrate, there are no exceptions to the rule. So right here, this one is soluble. So we're good with that. Alright, so now we have FeCl2 plus H2S. I don't see a problem with this one. I mean, all of them are, I think all of them are good. So, yeah. So now we have 2HCl plus K2SO4. Now we have the sulfate right here. And, we have the sulfate. Let's see. I have a chart here that I'm looking at so I can remember all the exceptions to the rules. Now with the sulfate, we are fine with that one too. Now, HCl plus NaOH. NaOH. So here we have hydroxide, and this is not soluble because we have Na, and that is. Oh, sorry. Since hydroxide is insoluble, what's gonna make this soluble is the Na actually. So this actually, Na makes it soluble. So if the Na wasn't there, this one wouldn't be soluble. So now we have FeBr3 plus BaOH. Now we have hydroxide here again. So right here we have hydroxide is always insoluble. It's just things that are in the product that are gonna hopefully make it soluble. Now, since we have Ba right here, Ba, that's gonna make it soluble. So yeah. So this is part one of double number 3.